So here we go. Section 4.3. Just like you guys said, Sohcahtoa. All right. If you don't remember Sohcahtoa, I wrote all this out for you. Sine. It's not sin, it's sine. It's the opposite over the hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Opposite is the side across from the theta. If you don't know that, I'll draw a picture in a second. Adjacent is the side next to theta. And your hypotenuse is the longest side across the right angle. If you know two sides of a right triangle, and you have to find the third one, what's that theorem that we use? A squared plus b squared equals c squared. Okay, good. So if I have a right triangle, no matter how it's drawn, guys, here's my right triangle. The easiest thing to do is to locate your hypotenuse first.
Which one's the hypotenuse?
It's the longest side across the right angle. There's my hypotenuse. As soon as you see a right triangle, no matter how it's drawn, draw that little arrow so you say, oh, there's the hypotenuse. So you're always going to have an angle of reference. We're going to call it theta. If that's my theta, what side is across or opposite, and what side is adjacent? Adjacent touches the theta. Opposite is across from it. So on this picture, which side is the adjacent? Is it the vertical line or the horizontal one? The horizontal. This is the adjacent side. And this is the opposite side. Okay, we have to get used to being able to label those things. So the first thing I would do is identify the hypotenuse. It's the longest side and it's directly across the right angle. And then you figure out which one adjacent and opposite is. Adjacent is next to the theta. Opposite is across from it. So if we have something like this, again, here's a picture for you guys to see. See how this is across. Here's my theta that we're looking at. So if they ask you, just using this picture, what is the sine, cosine, and tangent? Well, sine is opposite over what? Okay, so sine is opposite over hypotenuse. So what letters would it be?
Opposite, it would be C.
Opposite.
A over C.
A over C.
Okay, you know what?
All right, cosine is adjacent over hypotenuse. Remember, the hypotenuse is the longest side across the right angle. So adjacent, what would it be? B over C, good. Tangent would be what?
A over B.
All right, tangent. Tangent is opposite over adjacent. OA. So what is the opposite side and what is the adjacent side?
A over B.
A over B. You guys see that? So if we're talking about our reciprocal functions, guys, what is the reciprocal of sine? Instead of adjacent.
C over A.
Good. C over A. It's going to be our hypotenuse over the opposite side. Here it would be C over B, which would be the hypotenuse over adjacent. And then here it would be B over A, which is the adjacent over opposite. Our reciprocal functions work the same way. If sine is opposite over hypotenuse, if I flip that, the reciprocal would be the hypotenuse over the opposite, okay? We're going to talk about things in this way. Same exact thing we've talked about. Same exact thing we've talked about. But you're going to be given, in some things, probably not, maybe not this section, but the next one, you're going to be given an ordered pair. What is the ordered pair? It's the sine and the cosine, right? Yes? Yes or no? That's also the sides of the triangle. The x is the vertical, is the horizontal. The y is the vertical. You'll figure out the r. Do you guys see any way that you would? How does this figure out to this? This is just in radians. But how does this formula right here? What is that formula? It is the Pythagorean Theorem. So if you're given a point, you can tell what all the three sides are by using the Pythagorean Theorem. Do that in a second. All right. Trig values. I'm going to ask you questions in different ways. Some of them I'm going to say here, use your calculator to figure this out. Some of them I'm going to say you have to use right triangle trig with our special right triangles. We'll talk about that in a second. But if you look here, guys, what am I missing from this little tiny triangle at the beginning?
Hypotenuse.
I'm missing the hypotenuse. Could I figure it out?
Yes.
which would be what?
A squared plus B squared.
Over c squared, right? But if they tell me that the tangent is 3 over 2, what is tangent? Toa. Opposite over adjacent, right? So if they tell you the tangent of an angle, if they tell you the tangent of theta is 3 over 2, you can say to yourself, oh, that's the x and the y, so I can figure out what the hypotenuse is. When they tell you the tangent of an angle, and these are just similar, so you notice they all have the same ratio, but if they tell you the tangent, they're giving you the x and the y. Okay? Just putting that all together. So if I asked you to figure out all of these, find the 6 trig functions given this right triangle. You guys can all do this. You can all do this. Let's label the sides first. Which one is the hypotenuse? Hypotenuse. C, okay? Just because it's letter C in this example doesn't mean it'll always be C. But it's the longest side across from the right angle. Okay, so here's our theta. Here's the angle of reference that we're looking at. From theta, what is the adjacent side? B is the adjacent side. It's touching it. It's next to. And what is A? The opposite side. Okay, is everybody with me? Okay, I need to know numerically the 6 trig functions. I have 2 of the sides. How do I figure out the missing side? The Pythagorean Theorem. So I have a squared plus b squared equals c squared. C is my hypotenuse. So I know that one of the sides is a squared. I don't know what it is. I know the other side is 4 squared. And I know that the hypotenuse is 2 radical 5 squared, right? Everybody with me?
Yes.
Okay, so if we simplify this, we have a squared plus 16 equals. That 2 goes where?
On the outside.
Wait,
Where does that squared go? It cancels out the radical, but it doesn't. It also good. It goes to both things. Goes to 2 and to the square root of 5. So 2 squared is 4 times, you told me it cancels out the radical, right?
Yeah.
So this becomes 4 times 5, which is 20. So now what do? Subtract 16. So a squared equals 4.
and then you square root both sides.
So a equals 2. How come it's not plus or minus 2? Can't have a negative distance. Good. Good, good, good. So you guys are going to have to go back to your Algebra 1 geometry days and do some Pythagorean Theorem stuff. But now that we have all of the sides, we can just do real easily our trig functions. So from theta, opposite over hypotenuse. Tell me what I would write.
2 over
2 square root of 5.
2 over
Oh, it just
2 root 5, right?
is it
So what happens to the 2's?
Cancel out.
Good. So I'm left with 1 over root 5. Can I have that?
No,
What do I have to do?
you have to do.
Got to rationalize. So I have root 5 over 5. Very good. So now if I'm going to do the cosine, well, what's the adjacent side?
2.
From theta, what is the
4,
adjacent
4,
side?
4,
4 over the hypotenuse is what?
4 over 2 root 5.
Okay, so now what happens?
Would you like simplify?
You can simplify, so it becomes 2 over root 5. Now what? Good, you got to rationalize. Perfect. So you have 2 root 5 over 5. Perfect. Opposite over adjacent. Well, look at our theta. We already, guys, that's why at the beginning, it's the smartest thing you can do is to say what the opposite is, what the adjacent is, what the hypotenuse. It might even be easier if you do this. If you write opposite is 2. Adjacent is what? 4. And our hypotenuse, 2 root 5. Maybe that'll be easy. You don't even have to look at the triangle anymore. Right? It's just easier to say, oh, okay, this over this, this over this. So if I'm going to do TOA, TOA is opposite over adjacent. So it's what?
2 over 4.
2 over 4. Which becomes 1/2. Very good. Now if I do my reciprocal functions, I'm just flipping. So instead of opposite over hypotenuse, for cosecant, it's the hypotenuse, which is 2 root 5, over the opposite, which is 2. What happens to the 2's?
They cancel out.
So you just have root 5. Secant, hypotenuse over adjacent. Well, my hypotenuse is 2 root 5. over the adjacent is 4. What does this become?
Root 5 over.
Root 5 over. Perfect. And then here, adjacent over opposite. Well, adjacent is 4 over the opposite, which is, so that reduces to 2. This is all stuff you know how to do. Just because you have to rationalize with radicals, whatever. But maybe this would be easier for some of us. Identify the 3 sides, write them to the side, and then you don't even have to look at the triangle and be like, wait, which one's across from whatever? Just, there it is, list it out, you're good to go. Does that make sense? Okay. All right, good. Okay, this is the right triangle stuff. You guys have all seen this before, and some of you guys will be like, I just don't ever remember it. There are going to be times, I know for a fact on your test, you guys have a test. On your test, it's going to say, there'll be 2 questions, and it'll say, okay, what's the sign of 30 in a 30, 60, 90? And you cannot use the decimal. You have to know the patterns. You guys have to know the patterns. In a 45, 45, 90. You guys know what I'm talking about when I say 45, 45, 90? Okay, across from the right triangle is always the square root of 2. And the legs are always 1. Right? So the the hypotenuse is this. My opposite and my adjacent are the same numbers because those are the same angles, right? So if I asked you for the tangent of 45, you would tell me it's what?
It's 1 over 1.
It's 1 over 1, which is 1. You need to know this pattern. Because if I told you to find the trig functions without using a calculator in a 45, 45, 90, and I told you that one of the sides was 4, you can tell me what the other ones are. What's the other leg? 4. And what's the hypotenuse? 4 root 2.
Oh, okay. Gotcha.
Because remember, the pattern is 1, 1 square root of 2. Whatever the legs are, that goes in front of the square root.
Okay.
So if I told you that, and again, we're going to go over this a little more. If I told you that the hypotenuse was 3 root 2, what are both the sides? 3. Good. Okay, very good. How many of you remember this and go, oh gosh, I never really got that?
No, I got it.
Okay, all right, good. Good. That's wonderful news to hear. Okay, this one's a little more difficult. It's a pattern. The smallest angle is 30, so that's our 1. The hypotenuse is always double that side, and then the side across from 60 is root 3. So if I told you that this leg was 5, you can tell me what the other ones are. What's the hypotenuse then? 10. And then what's the side across from 60?
10 root 3.
No, it's 5 root 3. Yeah. All right, if I told you that the hypotenuse was 12, you can tell me the other stuff. What's the side across from 30? 6. And then what's the side across from 60? 6 root 3. Good. Perfect. Okay, good. Much better.
But that is like...
There's a million different ways to do that.
Okay.
If you learned it a different way, have at it. Okay, so now, if I tell you to find the exact values of the indicated variable, guys, when I say, or the directions say exact, okay, you got to be careful. Exact means radicals, because square root of 2. Do we know the square root of 2? No. We don't know the square root of 2. It's some sort of decimal approximation. So if it says exact values and there's radicals in the problem, that means you need to leave your answer in radical. But what do you notice about this problem? It's in what? Decimals. That means, we get to use what?
Calculator.
Our calculator, okay? This is a very, very, very important thing to listen to and remember. Guys, when you are given the ability to use your calculator, okay, very, very important, you have to make sure it's in degree mode. A lot of you will borrow from your friends. If they are in Ms. Boyd's class, or possibly in Ms. Chris Weiser's class, their calculator may be in radians. When you are finding the sine, the cosine, and the tangent using your calculator, It's not the same answer in degrees and radians. So you have to make sure. If you don't know, let me know and I'll help you. You guys already know how to do this. I know you do. I know for a fact that you do. But I have to find the sides of my triangle. Right? I want the indicated variables. Am I looking for sides or angles? Am I looking for sides or angles? Sides. I'm trying to find x and y.
Yep.
Now, I can use my trig functions, just like you did back in Algebra 2, just like you did in geometry. I can use a trig function to figure this out. Look at the information that is given. They gave me an angle measure, correct?
Yes.
What angle measure did they give me?
30.
32 degrees. All right, so from 32, what is 7.8?
The opposite.
It is the opposite. So the opposite side is 7.8. And they gave me the angle of 32 degrees. I have to find the adjacent and the hypotenuse. So I'm going to use trig functions. What trig function uses opposite and either adjacent or opposite and hypotenuse?
Wait.
Okay, tangent. If I'm going to use the tangent, I'm going to say tangent of 32 equals, what is tangent again? Opposite over what? Adjacent. So what letter am I finding right now?
Adjacent.
Which is what letter?
Y.
Y. So I'm going to say tangent of 32 is, what's the opposite? 7.8 divided by what? Y. You guys with me?
Yes.
Now I have a proportion.
Uh-huh.
You see I have a proportion. I have a left side fraction equals a right side fraction.
Multiply.
How do you figure out, solve proportions? Cross multiply. So 1 times 7.8 is 7.8 equals, can I multiply those two things together?
No.
No. So this is just the tangent of 32 times y. Or you can put y times the tangent of 32. Guys, this is the exact same thing. If you had 7.8 equals 3y, what would you do?
You divide.
You would divide by 3. The tangent of 32 is a number. It's just a gross number. So we just leave it as tan 32. So if I wanted to get y all by itself, what would I do?
By tangent.
Divide both sides by the tangent of 32. So in your calculators, now this is where it's important for you guys to show me as much work as possible, because if you show me this whole step and then you just have a calculator issue, that's a couple points off. But if you don't show me these steps that you understand how to solve and all you do is get some whacked out decimal, I can't give you credit. If you show me what you put in your calculator, I can help you out a little bit. But in your calculator, just hit 7.8 divided by tangent of 32 and round it to 2 decimal places. What are you getting?
12.48.
12.48? What are y'all getting? 12.48? Okay, good. So 12.48. That's our y. That's side y. So y is really 12.48. If they say it around to 1 decimal place, it'd be 12.5. Now there's a couple different ways that we can find x.
Yes.
What's one way that jumps out at you that you could do? You could do the Pythagorean Theorem. You could do 7.8 squared plus 12.48 squared equals c squared, then do the square root. You could do that. What's another way we could do it?
Just,
What'd you say, Hannah? Kaylin? Sine. I could do the sine, because what's sine again? Opposite over hypotenuse. So sine of 32 equals, well, what's the opposite side? 7.8 over the hypotenuse is what? X. Do you see again how we have a proportion? How do you solve proportions? Cross multiply. Guys, this is going to be the same way every time. This is how I generally write it. I write the variable first. How do I get x all by itself? Divide by the sine of 32. This is why it is so important that your calculator is in degree mode.
14.7.
What is 7.8 divided by sine 32?
14.7.
14.72.
Yes.
Okay. Now, I got here 14.72. A lot of you guys say to me, I just want to be able to check my work. If you do what I did here, tangent and sine, and you find 3 values, how could you check your work with the values that you're given on a right triangle?
Multiply them.
How?
I don't know.
Pythagorean theorem.
By the Pythagorean Theorem. Put in 7.8 squared plus 12.48 squared equals, and then take the square root of that. You should get something real close to 14.72. Is it going to be exact?
Yes.
No, it won't be.
Wait, 7.8 squared plus.
To check it, you can go
Plus 12?
7.8 squared plus, what was the other side we got? 12.48 squared. Okay, do that in your calculator. Tell me what you get. Okay, so you got 216 point what? 559. All right, some of you are like, oh my God, that's not even close to 14. Guys, remember this was a squared plus b squared equals what? C squared. What do I have to do to 216? Take the square root. So do that in your calculator. What's the square root of 216.59? 14.717. Is that mighty close to 14.72? Yes. So you can definitely check yourself.
Or could you just multiply 14.72 twice?
Yeah. Same thing. Same thing. Let's go into here. Oh my gosh, there's a lot of words. Guys, this is easy. We're standing on a bridge. We're looking down. We're standing on the ground. We're looking up. Okay? We're talking about angles of elevation and depression. If I'm standing on the ground, if I'm laying on the ground and I'm looking up at a tree, think about that, guys. If I'm standing or laying down on the ground, here's me. I'm the worst artist in the look. I'm just reading a book and I'm looking backwards at the top of this tree. Right? I'm looking this way. What kind of an angle did I form here? Is it an angle of elevation or depression? Elevation, because I'm looking which way? Up. All right? Angle of depression, you're looking which way? Down. Very easy. I'm going to ask you, if there's not a picture drawn, what should you do? Draw one. Okay? It's nice that they give you pictures and you can kind of look at it. All this is a right triangle problem with pictures and words. It says the irregular blue shape is a pond. Is anything about that important to my math problem? Nope. The distance across the pond, A, is unknown.
That's useful.
To find the distance, a surveyor took measurements shown in the pond. What is the distance across the pond? Guys, those words mean absolutely nothing to you. What letter are you looking for?
A.
Looking for A. So let's look at what they gave us. They gave me this. Whoops. They gave me this angle. Everybody see it?
Yes.
Okay, and they gave me a side of this angle in relation to, I should say, this angle. What side is this? Is this the opposite one? Is it the adjacent one, or is it the hypotenuse?
Opposite.
Look, what is given? Mia, is it across from the side? It's okay, honey. Thank you. Okay. Yes. What am I looking for? The opposite. Okay, so let's think about this for a second, guys. This is a really tough problem. It's super hard. I don't know if we can handle it. Is there a trig function that uses opposite and adjacent? What is that? Tangent. OA. Good. Opposite over adjacent. So it's the tangent of what angle are we referencing? 24 equals, what is the opposite side? What's the opposite side?
Oh, A.
A. It's unknown. I don't know. What's the adjacent side? 125.
Oh, right.
So look, one underneath this. You could write an A there. I wrote an X just because my A's start to look like numbers. Guys, I have a proportion. How do I solve a proportion? Cross multiply. We love it when our variable's in the numerator. Because look, all this is X equals 125 times the tangent of 24. That's all calculator work. It's helpful, though, if you write down what you're putting in the calculator. So if your little fingers make a little mistake, then I can see, oh, they just made a silly mistake.
How'd you break your arm?
All right, guys, so in your calculators, look, it's important that the tangent of 24 stays in parentheses. You can say tangent 24 times 125, or you can say 125 times tangent. You can put it in just like that. You don't have to have a multiplication sign. Just put your parentheses. But make sure that the tangent of 24, you got to hug it. Make sure it's a happy Tangent 24. All right, so what do I get when I have 125 times a tangent of 24? And we're talking about feet, so just give me, 2 decimal places.
55.65.
55.65 feet. Okay. That is how far it is across the pond.
Okay.
You guys are going to have word problems on your quiz. Test, I mean. It's going to be just a right triangle. Let's look at this last one, then we're done. A building is 21 meters high, and it casts a shadow 25 meters long. Find the angle of elevation. Okay, look at your picture. Everybody see your picture?
Yes.
Do you see the angle that we're referencing?
Yes.
Right here. Yes?
Yes.
What did they give me? What is the information that they gave me? The opposite and the adjacent. What is the trig function that uses opposite and adjacent? So I have the tangent of, well, do I know what theta is? God bless you. The tangent of theta, I don't know what it is, so I'm just going to keep theta as a quote-unquote variable. What is the opposite side? 21. Over, what is the adjacent side? 25. I have a proportion, right?
Yep, cross multiply.
Okay. So I'm going to cross multiply. I have 21 equals tangent of theta times 25.
I definitely did that problem in middle school.
Now what do I do?
Multiply.
No.
Divide by 20.
Divide by 25. Wait a second. We came out with the same thing that we started off with.
Oh, we
Are
did.
you cold or is it just...
It's cold in here. Guys, what is 21 divided by 25 in your calculator?
It's 0.84.
So tell me 4 decimal places.
It's only 84.
Just 84? Okay. All right, guys, we're looking for the angle measure. Does that make sense that the angle measure is 0.84?
No.
No. So everybody look at your calculator.
84.
No.
No.
Everybody look at your calculator. Do you see your trig function on the tangent button that says tan
Square root.
-1?
Yes, I do.
That is called the inverse. In order to find angle measures, we're going to write this down, you have to use the inverse. So you can write it as this. In your calculator, you can do tan -1 of 21 over 25, or you can do the decimal equivalent. But you have, most of your calculators, you have to hit second tangent, and it should come up on your calculator, a little tan -1. What do you get when you plug that in?
40.03.
40.03. Does that make more sense that your angle is 40 degrees? Okay, so, okay, we'll look at it. This is what I want you to write down, and then we're done. This is what I want you to write down. If you're looking for sides, you use sine, listen and write this down please, cosine and tangent. If you're looking, guys, if you're looking for angle measurements, what do we use?
If we're looking for angles, use tan of negative.
We use sine -1, cosine -1, tangent -1. That's really important. That should make sense to you guys. When you plug in your calculator and you get that the angle measure is 0.0223, and you write that down, that doesn't even make sense that an angle is 0.023. But you have to remember, if you're looking for sides, you just use sine, cosine, tangent. If you're looking for angles, you have to hit second sine, second cosine, second tangent. Got it?
Got it.
Okay, WebAssign is up. It is due Monday morning for 4.3.